All right, this is going to be the last part of this tolerancing assignment. We've added views to each of these 6 sheets, and now it's time to add some dimensions and tolerances. So I'm going to walk you through each page, and by the time this video is done, you'll be finished with holes, views, and tolerances. So make sure you grab a set of plans. Make sure you open up the file I have in front of me, and let's get started. A lot of the tolerances that we have that you've noticed as you read through them are 3 decimal places. And so let's go ahead. I'm going to show you how we can make sure that all of the tolerances we put on are going to be set to that 3 decimal place precision. We're going to go to Manage, and in the Styles editor, there's a drop down for dimensions. We are using ANSI default styles. And there's a tab here for tolerances that we can set to be at 3 decimal places. It's probably at 2 decimal places. So let's go ahead and just set that and save and close. We might have to set some individual dimensions to be 3 decimal places as well, but we'll do that manually. If we start with the column, there's going to be on this view from your plans, it has a unilateral tolerance. So we're going to place that unilateral tolerance so it looks like it does on the plans that you drew it from. Under the Annotate tab, we are going to go under Dimension. And we want to pull the dimension straight down. We're going to dimension this gap right here that was drawn to be 0.5 inches. Now, if I don't select the actual line and I select the endpoint, it might not pull in that downward direction. So make sure you select lines here. Okay. And it tells me it's 0.500. That's exactly the precision I want. If for some reason yours just says 0.50, you can change that right here under the precision. Okay. That would be under the precision and tolerance tab. And as I look through some of these, looks like it says tolerance method, I can scroll through these and see different styles of tolerances. And the one that says deviation allows me to add an upper and or lower limit. Tolerances do have to get put in manually, so I do want a 5,000th tolerance. It does update here. So this could only be bigger than 0.5 by 5,000ths. It could not be smaller because there's a part that slides in and out of here. I'm going to click OK. Make sure that you don't want to have this half off the page. You have to do a little bit of cosmetic arranging here so it looks good. So that's how to add a unilateral tolerance. We're going to go ahead and also add a hole note to this. So remember, there was a counter bore hole that was on the side of the column. Anytime we add a hole note, we're going to use this option right here. We're not going to dimension it. If I do use dimension, it just gives me the diameter. But if I use hole and thread, I get all that good information that we entered. And I've got some good tolerances here. Let's take a look at what the hole note says. I want it to look just like the answer key. Okay, so I've got the right diameter. This was not in the hole note, the depth. So I'm going to show you how to remove that. My counterbore diameter is to the right precision. I'm going to have to add a bilateral tolerance, and then my depth is correct. So to edit this, I'm going to double click on it. We've kind of got some coding going on here. So let's first get things into 3 lines. So right by this depth, I'm going to put that on a new line. And just by doing that, see what happens. See, it just moves it down to another line. I'm going to get rid of the depth of 2 inches. That would be this right here. And on the second line, I'm going to add a bilateral tolerance. I'm going to have to do this manually. So I'm going to click on this drop down and choose plus or minus 0.002. Let's click OK. And this is the exact hole note that was showing up on our plans. Sheet 1 is done. So let's go to sheet 2. Sheet 2 is the base. I've got hopefully all my views placed, and I'm going to place a thread note on this hole here. This is where the column is attached to the base. Again, I'm going to use hole and thread. I'm going to select this outside portion. When placing a hole or thread note, we never want to place things straight down or straight to the side. We always try to go at a 45-degree angle, or at least somewhat of a 45-degree angle. If we look at the hole note that's on our plan, it says 3/8-16 UNC, but then it gives me a depth that did not get included in here. It did give me the -2B. I'm going to end up deleting that. So I'm going to double click. I'm going to delete this portion right here, because that's that -2B. And on the second line, I'm going to add a symbol for depth of, and I'm going to put in 0.750. Ooh, that would duplicated itself. So I'm going to, it knew that the hole depth was 0.75. So, we have to add the symbol. So we included the information about the hole here. I need to add the actual symbol. So I'm going to go over here and I'm going to use that symbol. There we go. All right, so sheet 2 for the base is complete. We're going to go ahead and move on to the sheet 3, which is the punch holder. Let's take a look at this view right here. I am going to add a hole note for this 45-degree angle. And if we look at the plans for the thread note, or I'm sorry, for the thread note for the punch holder, it just says 1/4-20 UNC, which it does. One of them has got a depth of 0.3. And I think what we should do here is let's get into editing this. And there's no reason why we can't make both of these the same. So 2x, we've talked about what that means, 2x. And on the second line, I'm going to give my hole depth information. Let's see what that updates to. Okay, we're not quite there. Oh, I think I clicked on the wrong one. I'm sorry. This one right here, hole depth value. There we go. And of course we need the symbol. So we're going to go up here and add that symbol. There we go. So both of these holes are the same. We're going to add some dimensioning on our auxiliary view. So the dimensioning that all of these placements of these holes were based off of this line right here. So I'm going to dimension. Again, this is where I have to select the line itself. So from the center point to here, this is going to allow me to align that dimension. Okay, if you don't click that line, you just click this point, it's not going to want to go in the right direction. You could always right click and try to align it. That didn't work either. So do make sure you select this line and that point. We should automatically be at 0.336. Okay. And we are going to keep dimensioning. This is called chain dimensioning. Oh, I'm sorry, this is called datum dimensioning, where everything is based off of one point. Now, if you get a dimension here that doesn't seem to want to follow directions, just right click and align it. Oh gosh, that didn't, I might have selected the endpoint. There, that one. There we go. We want to space these out so that we have some room. We don't want numbers to be overlapping. You could move the numbers a little bit to make some room. This is the part of dimensioning that, again, is, we'll call it cosmetic. You need to make it look good. Not only are you communicating, but you're communicating clearly. All right, so we have all of those aligned dimensions. And we also have a hole note for these. All of these holes are the same. Let's kind of give them that 45-degree angle. 0.226 with a depth of 0.4. All of these four are the same, so we will tell them to be 4x. They'll all be drilled the same. Perfect. We're going to move on to sheet 4. We've got a half section view. One thing that I want you to add to this is we are going to project a view of the section view. So we can do that under placing views. We're going to go to projected. I want to project a view from this, which means when I project it, look at that, it's going to look it's going to look like it's got a chunk taken out of it. This is kind of helpful to see sometimes. See what it looks like. We're going to add some dimensioning to this. That gear plate had some interesting dimensions on it. It said that the holes were a certain degree apart from each other. It's kind of tricky to dimension that on a part, so we'll kind of follow along here to get that done. The first thing that we'll do is we'll dimension the hole. So this is going to be just a regular old hole. That's what through means, regular through hole. And all three are the same, so we will give this a 3x. Through, all right. Now, if you look at your packet for the gear plate, we have to dimension 120 degrees between each hole. We have to let the designer know that. So let's take a look. There is a tool here called centered pattern. That's really what we're trying to dimension here, is a centered pattern. I'm going to click on that. Inventor is telling me to select the center of the circled pattern. Well, that's going to be either one of these circles is going to tell me where the center is. Okay, so I've got a little cross that's telling me that that's the center. And then I'm going to start clicking on these circles. And you can see I'm starting to get that circle that's drawn in a center line. And I'm going to create it. That gives me, okay, and remember on the plan, you dimensioned this as a radius. So I'm going to go to dimension type, radius, 0.725. And when I did the circular pattern, I have these little markers on here. Those end up being really useful so that I can use those to dimension 120 degrees apart. You might need to rewatch that. If you get it right on the first try, you're doing pretty good. It's a tricky dimension to put on. But that's going to be it for the gear plate. All right. On to, as far as tolerancing goes, we're not adding any tolerances to sheet 5 or sheet 6. So why don't you go ahead and save this? You're done putting in all of your dimensions and tolerances, and you'll wait for further directions to finish this assignment.